A teď následuje Saša, který pochází z Gruzie, ale momentálně studuje v Praze podnikání a miluje to tady. Takže jeho zájmy jsou pestré, umění, programování, světová historie, věda, co vás napadne a díky své zvídavosti a nadšení nikdy nevyčerpá témata, která může se svými studenty objevovat. Jeho výuka je tedy živá, otevřená a plná inspirativních rozhovorů. Saša nám ukáže, jak popularizovat vědu, aby bavila nejen odborníky, ale i běžné lidi a děti.
Okay, Tekla, thank you again for your demonstration. And now it's time for Sasha, who comes from Georgia, but now he's studying in Prague. He's studying business administration and he loves it here. His interests are very diverse. It includes art, programming, world history, science, anything that you can think of. And because of his curiosity and passion, he never runs out of topics to discuss and discover with students. So his lessons are very open and alive and full of inspirational talks. So Sasha will show us how to popularize science so that it would be fun not only for professionals but also for common people and especially children.
Thank you so much. Hello everybody, greetings. I'm Aleksandre, but everybody and my students call me Sasha, and you may so as well during this entire presentation. Today, as we were told, I will be presenting what I tutor kids in and what I present for kids to learn. Science, and I call it Science and Friends because it's adjacent to science subjects. What do I mean by that? We'll get to that. So let's a little bit expand on who I am and where I come from. I come from Georgia, Tbilisi, as many of my colleagues. As I've been told, I study in Prague on business administration, but don't let that fool you. I finished the young engineering program in UG Limes, which was a school for engineers in Georgia. I've also finished IT Step Academy with all the programming courses, engineering, and graphic design courses. I've done this so outside of my school because it was more of an interest rather than something I wanted to pursue in my life, which is why I study business administration. That's something more focused on my career. And the others are interests, but we can talk about other things too with my students. So here are some pictures of where I've been, like specifically what I've done. In the middle, you see me on science fairs. I've attended every science fair held in my high school by a university in my country. It was like a public display. Every school would come with some different projects. And this is me with my vacuum cleaner bazooka, which was just basically a bazooka we built from a vacuum cleaner utilizing like physics of air pressure and pressure changes in the tube. On the right is me currently promoting Study in Prague program for my university. For those who are interested in studying in Prague, I'm like an ambassador in my university. And maybe for a fun fact, I will put on the left a picture of me on a fencing tournament here in Prague. Because so that my students don't think I'm just a nerd. I'm a nerd with a sword. So I can also talk about sports and different kinds of all sorts of stuff. I don't know, movies, arts, whatever it is, it's fine. I've taken class for it all. Now a little about what I teach. Let's come back to what I teach. First thing that they mentioned is science. I teach fundamentals of science. That's how I call it, because my other colleagues, Arina and Tekla, showed a very wonderful demonstration of some more practical, practical applications of more specific kind of branches of science, whereas I teach more theoretical, more general kind of science. That's the type of stuff that kids can come up and tell you as a fun fact. And something to keep in mind. So we don't really utilize that much mathematics. For example, down here, I have a screenshot of me teaching our excellent student, Krzysztof, what is the observable universe without using much formulas or anything. And I would like to ask the audience, does anyone in the audience know what the observable universe is? I would like to answer. If not, does anyone in our staff want to answer? That's excellent. So an observable universe is simply what we can see, what kind of borders and the edge of the universe that we can see from Earth. Because I was explaining to Christoph using like my doodles here that since objects in space are so far away that they're millions and millions and billions light years away, actually the technology we have currently doesn't reach that far as vision goes. So we actually don't see that far away into the universe. This is our limit of where we see. Of course, there's universe above that too, but this is what we see. And also we see back in time because it takes time for this light to travel back and forth. So we are seeing planets in our solar system back in time and not currently. Something that was interesting to my student. So stuff like that. Another time we explained, for example, Mendelian genetics and inheritance, which is very easy. It explains how kids, very simply, how kids inherit different traits from their parents. And we did some exercises and it was fun because it's all visual and you have to connect dominant and recessive genes together and then tell genotype and then phenotypes. That was that. Of course, I use, as they talked before, content and language integrated learning, since I'm teaching science and programming, but especially science needs a lot of scientific terms, words that students need to learn. So you can't really learn science in English without learning English with it. A lot of things are like that. And also because a lot of words in English come from scientific theories. So we learn a lot from these. Another reason why I think science is fun, because the question is like, but Sasha, why science? Why did I choose science as like something that I'm interested in, even though I study something else? Well, because again, even on a theoretical level where you don't do much calculations, you can still learn a lot about the world you live in, and then you can use it to do cool things with it. I'm going to bring some examples that might or might not be too applicable in the world, but I think it's still interesting to talk about. For example, on my left here, I have a picture of Japanese macaques, which have been observed to play and have fun with snowballs, which is an interesting trait to have on an animal, which really does make you think about the theory of evolution. But we had shared the same ancestors with those guys. In the middle, I brought an example of one of Galileo Galilei's theories that in vacuum, a bowling ball and a feather fall at the same time. So if you let go of a bowling ball and a feather in a vacuum where there's no air, these two fall at the same time. Now, logically speaking, you can imagine a bowling ball is much heavier than feather. So how does that happen? Well, you don't have to believe me. Actually, I have a video right here where I can show you how those things happen. So we have with air resistance, the bowling ball, of course, comes first, ruptures the surface first. Feathers fall very slowly in slow motion. But yeah, this is without the air resistance. So this is in a vacuum tube. You will see they fall exactly at the same time and fall almost exactly at the same time. Well, rarely, like feather is a bit faster because it's longer, but not that it's heavier or anything. Now, my students, of course, have a question. Why is that? The reason of the behind that is actually pretty simple, which is interesting because science is anything but simple, but sometimes it is just that simple. The formula of force is F equals m times A, where F is the force, m is the mass of the object, which is what people usually associate with something being heavy, and A is acceleration, which is not at all the same as speed or velocity. This is something else. But I would bore you if I were into the details. That's a different lesson, a different 50-minute lesson to explain to you. But again, this is what it does, that while the bowling ball has a bigger mass than a feather, it doesn't have more acceleration than the feather. Actually, due to something called inertia, the acceleration of the ball cancels out the free fall. So it's a bit complicated, but I'm not gonna go into that now, which is why we can have a lesson about this. And finally, the third one example is, did you know that boiling water, hot water, freezes faster than cold water? Actually, that's not true. So something about my lessons, about my science lessons, is that I always tell my students that they should always check, well, not always, but mostly it's a good practice to check what you're being taught. So like fact check me. I teach them how to do this with different websites that we use, but it's always good to fact check because there are a lot of myths surrounding a lot of scientific ideas. The most popular one being golden ratio. People to this day don't know what golden ratio is. Also an excellent lesson that I had. But in this case, yeah, does hot water freeze in cold water? Does hot water freeze faster than cold water? Question is, the answer is a little bit complicated. Yes, but also no. It depends on how you conduct the experiment. We have research that shows that yes, sometimes hot water does freeze faster than cold water, which is interesting. That effect is called the PIMBA effect. And yeah, that's something that does happen, but it's also something that you might not be able to replicate at home correctly. But there was also a trend on the internet where people used to go out in kettles with hot water and throw it in snow and see the water freeze, which is not safe. Don't do this at home. A lot of people got injured, but yeah, sometimes it does happen. So the answer to that is kind of yes, kind of no, depends. Something to keep in mind. Next up, we have the question of, oh, sorry, before that, another interesting fact is light can move objects. Something people don't expect usually, but yeah, light is strong enough, depending on luminosity and the amount of energy, you know, not energy, but the way the particles and the waves in the light, called photons, behave. Depending on that, they can also move objects if the light is strong enough. Also a lesson. Another one is associated to this is the double slit experiment, which is really fun and something that you can replicate at home. Now, on to the next topic, being like, okay, Sasha, what about programming then? Why is programming interesting? Well, I think the answer is pretty simple. Programming, you can do a lot of things nowadays with programming, especially with AI getting smarter and really good at programming. You don't need to you don't really need to know as much in your head. You can always employ the help of an AI to fix your code. And the way we start teaching in my class, the way we start learning in my class programming is with Scratch, which is such a simple method to make a student understand how code executing works and how programs work behind the scenes with colorful interface and like stickers and funny characters to look at. So it's really easy for kids to understand how if cycles work, how while cycles work, while not also having to remember how to write them in real code. Which makes me go to my next point, the real code. Real code is like a language. I'm speaking to you in English. I understand a little bit of Czech. I understand a lot of Georgian. It's all of these languages have different syntax, different grammar, and same happens with programming languages. I teach Python and C++, and while they might look kind of similar, this one in the picture is Python, it's still different. It has its own sentence structure, it has its own way of writing things, and it has its own way of punctuation even. Python does not, almost. There is some minor punctuation, but almost has no syntax. It writes like a sentence in English. And it depends, that depends on how it influences how the code works, the way you write it. And after you learn how to do this very mathematical and very statistics-based Python coding, and we can finally get to the good stuff, the object-oriented programming, which is applying it in 3D space or in 2D space, where you can write code to manipulate objects and create your favorite video games at home, all by yourself, because programming is very, very accessible nowadays, and a lot of tools are free. So something that we can learn. Now let's talk about the marriage between these two spheres, science and programming. well, of course, these two are very interlinked together, but I think the best example of that is cryptography. Cryptography is the study of secret messages. So something that you used to send to your friend in middle school has a whole science behind it. So like secret messages, so something that only you two can read. And where does this come from? Cryptography and cryptology has existed in ancient times. They've been sending each other secret messages since ancient Rome and even before. But I think where my point comes in is with the Enigma machine and the invention of the Turing machine. So the Germans during World War II had an Enigma machine depicted on the left, a machine that was able to scramble the alphabet, mix it up, the letters, mix it up, the 26 letters of the alphabet, and show you a different message, an encrypted message. The way it worked is using these rotor blades right here. They mix up, there's a whole combination of how they do it, and they had keys sent to each other. So the way these rotors were scrambled. So only the two people who had the same Enigma machine and the same keys were able to decipher the code, nobody else. Not entirely true. The mathematicians in England were able to decipher it, but by hand. They sat down, used all these graphs of paper, and deciphered the messages by themselves, by hand. The problem was it was too slow. And by the time they found the message, a new message was created, a new code, new key was created. So they had to start all over again. So Alan Turing, being the British mathematician himself, created a machine that was able to do it faster than a human brain and hand could. And this is actually, in my opinion, and opinion of many, the oldest computer. It's like the grandfather of a computer. This was before semiconductors were a thing. This was before like binary system and stuff like that was created. This is technically the grandfather of the oldest computer, the Turing machine. And this was able to do exactly what Enigma machine did, but in reverse. And more like it was able to see all possible codes until it got a sentence. So it was able to, they put in an English word, and if the computer found, if the Turing machine found the same word, well, actually not English, sorry, German word, if they were able to find a German word in the code, that means they successfully cracked it. And that's how they were able to actually win a lot of battles in World War II. The way I would like to show you where this comes in with us is ciphers that you can do by hand. This is very fun. I used to do this as a student, like when I was in school. So we have the Atbash cipher, which is the simplest one. You take the regular alphabet and you flip it. You reverse the order where A is now Z and Z is now A, and in reverse order. So your new message is using these letters right here. So instead of G, you write T. Instead of E, you write V, etc. Something to understand, the regular text that you will write, for example, my name, Sasha, is called plain text. And the text that comes out at the end after encrypting is called ciphered text. So in this case, there will be something like H, Z, H again, S, Z. So something like this. This is the Atbash cipher by my name. There is also something really, another old cipher, which is the Caesar cipher, this one. The whole point of this is that instead of reversing the alphabet, imagine a wheel where you spin it around. You spin these by either left or right, and by how many you turn, for example, in this case, they turned it right by 3 keys, 1, 2, 3, and we got this one. So now D becomes A, E becomes B, but A, B, C are X, Y, Z. And you write your new message like using this kind of alphabet. But know that it's shifted right by 3 keys. This is what they call it. And finally, an example of hieroglyphics, which you would know. Ancient Egypt and a lot of ancient civilizations used hieroglyphy as a language, but you can also use it to hide your regular language. So we have a Freemason cipher, which is just this hieroglyphs associated with letters. Pretty simple stuff. Finally, I want to get to one of the complicated ones, but I think one of the most interesting ciphers, the Visionaire cipher. The way this works is we write a sentence like this one. Sentence says, we attack at dawn. You put them together, and then you choose a key. Your key in this case, unlike in Caesar's case where a key is like shifting right or left by number, in this case, a key is a word that you choose. In this example, they chose lemon. So what you do is, this is your plain text, your sentence that you want to be a secret. You have a key, which is lemon, and you write lemon, and exactly the amount of times as you have letters. So they wrote 1 lemon, 2 lemon, and LE, because there's no more space to write more lemon because the sentence ends here. And then what you do, this is called a key stream. What you do with this is you consult the graph of the Visionaire cipher, and you search for these 2 letters. So my plain text has A in it as the first letter. I found A, and it has L. So we find A and L. And here's our secret letter, L. Now let's find T and E. We find T right here. We find E right here. And the intersection of these letters is X. So we have X. And if you go like this, you will get your ciphertext, your secret message. Now, I hope that's understandable. If not, I can always come back to it later to explain. And now I want folks who are here and folks who are at home to encourage a small activity. Get your pens, papers, telephones, or tablets, anything, because you can do this online too. Use whatever tools you want, but I'm pretty sure ChatGPT gets stuck on this. And I would like you to decipher a secret message that I gave you. The only hints you get is that the last sentence that you're supposed to get, the plain text, is supposed to be an English sentence. And your hint is 29 shifted left. You can screenshot this for those who are watching, or those of you who are in the live audience, and can decrypt your message at the end. And my question is, can you crack the code? With that, I hope, I have to end this lesson, but it doesn't have to end here. We can always meet again. And I would like to ask for any kind of questions, anything that you might want to share from previous slides, or again, any questions to me.
Okay, thank you very much for your presentation. It was really informative. And I wanted to ask, how do you see the role of programming skills in today's scientific research?
Oh, excellent question. I think I want to start answering like this. In general, nowadays careers are like more jobs want people who have multiple different technical skills, not only soft skills. In research, where programming is such an excellent tool for statistical research by default, you will need someone who not only knows how to not only understand the subject. For example, if research is in biology, not only it is nice to have someone who has the biological background of knowing biology, but it is increasingly helpful to have the same person be able to program your statistical formulation and do statistical analysis in R programming, which is a language reserved for statistical analysis, one of the best ones. So to do the same, but in computer, it is obviously much faster than Excel or well, there are other tools that also do pretty well, but I think programming gives you freedom of configuration. You can do practically anything if you know how to do programming. In a virtual space, you can do anything and whatever. You can also create visual distributions in your own program and show them, and you can do mostly anything with them. So it's really quick. It's really It's really quick. It's efficient. It's quick. It's also teaches you this practical skill to have. So, for example, if you learn how to do statistical programming, you might also be good at it is easier for you to learn Excel, how to use Excel sheets for something completely unrelated like business and accounting. But it's also you are prone to learning how to do software development, which is like websites. This all like give you gateways, I think that's a sufficient answer. Yeah, it's and also it's programming. They say that in order to be a programmer, you need to know maths really well. My answer to that, you don't have to, but it's of course helpful. Like a better programmer is someone who thinks mathematically, but you don't need to. You can still do programming. It's just programming needs mathematical thinking. Obviously, you need problem solving that you are taught in math. And if you don't know, then programming teaches you how to do problem solving in math, on some level.
Thank you. That makes a lot of sense, actually. And I also wanted to ask if there's like a recent science or tech project that you've worked on, or maybe something that you saw that you found inspiring.
So I haven't worked on a science fair project in a while. I do programming, but like as a hobby. If I teach my students, I do that, or I help in game development. I get hired and commissioned to do art for game developments, but knowing programming, for those who know asset creation, which is what I do, asset creation, background drawing, and stuff like that, it's increasingly helpful when I understand what they have to work with, because what I give is already applicable. Like straight away, you can just put it into the program. I built it to the dimensions and the format of the program, so it's easier for me to throw in. I guess that will count. I also sometimes write programs and make like small video games for my sister on her birthday. But as for science, I'm very excited for the developments of the quantum computer. I wanted to talk about that because the video that really inspired me what to do for activity time was quantum computers, because people like have a lot of opinions on it. But I think the first thing that they think about quantum computers is the speed at which it encrypts data. How much more difficult it will become to hack into a system when you have quantum computers, because their encryption method is a whole different level that we have yet to see before, because they utilize superposition, which is like such crazy theoretical physics that I can't believe that we humans were able to capture it on a small like a small chip, microchip, yeah. But we have to cool it down and have to use actual gold in it. Very interesting stuff. So that.
Okay. Thank you. That's all the questions for me.
Thank you so much.